All right, for 47, it says given constants, so numbers, c, d, m, and n, such that x squared plus mx plus c has the factors of this and this. So I know that means that this can be divided evenly, and this also means that these two things can multiply to get that. And then it says x squared, this one has the factors of that and that, right? So they really want to know, like, if I multiply these together to get that, and multiply these together to get that, what is m times n? All right, so if I do quick box method for the first set, I get x squared, 2x, 4x, and 8. The middles are 6, so x squared plus 6x plus 8. So I know that m is 6 and c is 8. And then on the other side, we have x plus 3, x plus 7. So I have x squared, 7x, 3x, and 21. This would be x squared plus 10x plus 21. And we know that that would be n is 10 and d is 21. Right? So, and they're asking specifically for m and n. So 6 times 10, 6 times 10 would be 60. So your correct answer is D. They really just want to know the middle terms. So if you could figure out that they just care about the middle terms, you don't even actually have to do this part here. You could just figure out, like, okay, that makes 10 and this makes 6, so 6 times 10 is 60. All right. Just wrote on this one. So for every angle theta measured in radians, which of the following is equal to sine 2 pi plus theta? So theta is just like x, right? Anytime we see theta, we can just have an x in it. So and x can be any number that we want. So let's call it 10. Right, we'll call it 10, that's fine. So sine 2 pi plus 10 is what I'm gonna put in my calculator. The one thing that it says here though is that it's in radians. So when I go to my calculator, I see that up here it's in degrees. I'm gonna go ahead and press the mode button and go down to radians and press enter to click it into radians. So now I'm in radians. So I'm gonna put in sine of 2 pi plus 10, because that was a number I chose to plug in, and I get this number here. So negative 0.544. Oops. So that's the number that I'm looking for when I type these things in. So remember that I turned theta into 10. So for the next one, if I'm gonna look here, I'm gonna do plus 10. So sine negative pi plus 10. That's the same number, but it's not negative, so it's not f. Sine of 10. Oh yeah, that's exactly the same number, so my answer must be G. I can quickly check the other ones. Half pi, that's not it. Sine 2 pi over 3 plus 10, that's not it. Sine pi plus 10, that's not it. That's the other version. So I know it's not these ones, it must be G. For my pre-calculus people, you know that 2 pi is the same as just going around the circle one time. I remember 1 pi would be here and a second pi would be here. So then you know that that's really like just starting the problem over again, so that doesn't really matter. So it's really just the same as sine pi. Okay, and we can see sine pi is right there. All right, so my pre-calc friends who know how to work with radians, you can do that. One thing to be careful of, you should turn your calculator back into degrees. So press the mode button, go down to degree, press over, press enter, and then you have your calculator back in degrees. Cool. For 49, it says a small circle and a large circle are tangent at t, so they touch at t, as shown in the figure below. The center O of the large circle lies on the small circle. The diameter of the large circle is 12. So I know all the way across is 12, which means I know halfway across is 6. What is the ratio of the area of the small circle to the area of the large? So I need the area of the small, and it's here in fraction mode, so area of the small over area of the big. So I need to know the area of the small and the area of the big in order to compare them. So pi r squared sounds like area to me. So if I'm doing the small one, I know it's pi times r. In this case, halfway across here would be 3. So I know this is 3 squared over the big one. the radius, if the diameter is 12, then the radius is 6, like we said. So this would be 6 squared, right? I see that this would be 9 pi over 36 pi, because 3 squared is 9, 6 squared is 36. The pi's will cancel, and that leaves me with 9 over 36, which is not one of my answers, but if I do math enter enter, 9 divided by 36, math enter enter, I get 1/4, and that is one of my answers. So my correct answer is A. Finally, I have 50. There are two big ways of doing this problem. So it says, for all positive values of A and B, which of the following expressions is equal to 2A plus B, or over B, plus B over 2A? So the first way is like the guess and check way. So let's just use the numbers 2 and 3. So I'd have 2 times A is 2 over B is 3, plus B is 3 over 2 times A, which is that. So this would be 4 over 3 plus 3 over 4. I'm going to go to my calculator, type 4 over 3 plus 3 over 4, and I should get this as my answer, 2.08, which then I would have to plug in each of these. So like 2 times A is 2 plus B is 3, and then I have 3 plus 2 times A, which is 2, and I get 7. 7 divided by 7 is not 2.08, so I know that F is not my answer. I could keep trying on these ones. I would have 2 times 2 plus 3 over 2 times 2 times 3, 7 over 12, but that's not going to give me that 2.08 answer either. So I know it's not G, right? So I can see like this process takes a little bit of time, but eventually, let's see, 4 times A is 2 plus 3, which is B, divided by, I already did 2AB, which is 12, so that's not going to be it either. 4A squared plus B squared divided by 2AB, which we said was 12. There it is. So I know my answer is J, right? A slightly faster way of doing this, if you know how to add fractions, is to say, okay, I want to have the same denominator in order to add them. So I'm going to multiply this one times B, because that's what I have over here. So B is on top. And then this one times 2A, because that's what I have on that side. So 2A times 2A would be 4A squared plus B times B is B squared over 2A times B is just 2AB, which is what you can see here. All right, so you can guess and check. It will take a lot longer, or you can add fractions together if you would like to do it that way. That is number 50.